Hello YouTubers, Tross here. Back with some more Factorio, but this time I'm not doing a playthrough or anything like that. I'm doing a training. A little bit of a tutorial on how to set up and use trains properly. Just had I've seen a few people have questions about setting up trains or getting a little bit confused. So I'm going to try to give my overview of how to use trains as simply as you can, and get them working right. I am currently in a creative mode. Creative mode's a mod, but it's basically the vanilla game, but you can spawn in whatever you want and build whatever you want, and it gives you a few extra things like power sources, and particularly I have matter sources. This will put things on belts. This will eat things off belts, and then the same for fluids. Just to show you, how to set this up without, having to build a whole base here. So basically, at some point, you're gonna exhaust anything close, material-wise. All your iron mines, or copper mines, or coal mines, or stone, etc. And there are further, there would be further places out, but running a belt or several belts, because you'll probably need several belts worth of materials at that point. It takes a long time, and you don't get the materials that fast. At that point, that's the point. Well, just before you get to that point where your close iron or whatever runs out, you want to set up a train system. Oh, it looks like, yeah, it also unlocks all the technology for you, but, well, the main one you want is railways to get started, and, that unlocks after you get engines. And then, from there, you want automated railway transportation and rail signals. You're gonna want rail signals almost immediately after you get automated railway transportation. You'll also want fluid wagons if it's oil you need to go get. And eventually you can do braking force. These will make your trains faster by making them stop faster, which basically, as the description says, if they can slow down faster, that means they can stay at high speeds longer. But these are not really needed at first. Definitely you want railways, automated, and signals almost at the same time. And if oil is your issue, which a good percentage of the time it may be, you also want the fluid wagons. But yeah, as you can see, these are all blue science or above, so you don't need them right away. The easiest thing to set up is you take some rail, which is, all your railway stuff is right here in this one row. It's just some stone, some steel, and some iron sticks. Relatively simple to make. And you want to put one piece down. And if you have bots already, you'll want to then hover over the one rail piece, move your mouse so that the arrow is pointing in the direction you want, hold shift, and click and drag, and this would lay out a big long ghost. You can move it around to wherever you want. If you continue to hold shift, this will go right through, like this is a rock. You can see it's red, but if I click, it will play, well, because I'm in creative mode, this would place ghosts, but it would automatically mark the rock for deconstruction, and then your bots would place, pull up the rock and place all the rails exactly as you just did it. Basically, because I'm in creative mode, I have instantaneous bots. Now, if you don't have bots, well, what do? Well, you go back, you have your one piece of rail. You don't hold shift, and you just click and drag out. You can still go around in different angles, but you're limited to basically your reach distance. But I can click, and even if you don't have bots, it will place that much at a time. Let's say I wanted to go around these rocks rather than digging them up. You know, you just keep continue placing where you want. When you're holding shift and start it off, like if I want to go here but not to the west, I can press R, and you can see it will rotate the direction that the end of the track is facing, and it will just plot out the best way of getting there. And of course you can hit Q to cancel. So let's use this straight piece of rail I placed earlier. So what you're going to want to do is build 2 train stops. They're just some circuits, iron plates, and steel. And you want to put them on the side of the rail. Now, there's some important distinctions to know. Trains only obey things, or everything needs to be on the right-hand side of the track as viewed from the train. So if this is the end of our rail, like this is in our base, and out this direction to the east is some resource that we want, we can't put the train stop here. As you can see, as I put the train stop, it has some arrows, and that's the direction the train is expected to come if it is stopping at this train stop. So if we want the train to come in from the east, we have to put the stop on the right-hand side of the track from the train's point of view, like up here. Now you can see that the arrows are pointing into the station from the direction that we want our train from coming in. And in this case, I'm just going to put it at the end of the track because we want this to be the end of the station, the end of the rails, and for the train to come in and then leave. So then you need to build some locomotives. That's some engine units, some electronic circuits, and some steel. And that takes actually a little bit of materials. And we're going to want 2 locomotives for what we're setting up. And we want at least 1 cargo wagon, which is also some steel, some iron plate, but this time just gears instead of engine units. So I'm going to do things simply. I already have some built up here. The train has a facing, like this is facing into the station. In fact, it snaps to the station when you go to place it. The little white outlines are showing you where the different cars of the train would be. So I'm going to put one in the station facing into the station. I'm going to put 1 cargo wagon down. And then I am going to put another locomotive, but this time I'm going to flip it around by pressing R. So it's facing the other way. That's the simplest train you can make for normal things. Now, if you haven't, you need to fuel these with fuel. You can see the little fuel. They'll take anything that will burn in a furnace. I happen to have some coal here. We'll do 50. That should be more than plenty. If you haven't researched automated railways, which, I mean, you really should, then the only thing you can do is get in the train and drive it. I'm pushing W to go forward. You can let go. You can see smoke stops and it'll slowly slow down, or you can press S to stop. Once it is stopped, you can press S to back up. In this case, I have another locomotive facing the other way, so the train will go fast. If you only have a single locomotive, the train will back up. It'll back up slightly slower. The thing is, the train will only back up under, if you don't have a locomotive facing in both directions, it will only back up slowly and only under manual control. Slowly is about half speed. In order for it to automatically go back, you need a locomotive facing each direction. Under automatic control, the locomotives only go forward. So let's drive out to our theoretical ore patch. So here's our theoretical ore patch out here. Now we want to put this station down, and we need it now on this side because that's the way the train came in. We'll give these a name. We're not going to go play Ultimate Frisbee. We're going to call this Get Ore. and oh, it's not far. I'm gonna run over here, click on this one. I call this drop off. So we need to load ore into this car, but where exactly is that? If I hold a inserter, you can see the outlines. Now, I did not drive the train into the station properly, so the train isn't lined up. But under automatic control, these white outlines are showing you where each car would be. So since we only have one cargo wagon, we need to put the inserters somewhere along here. There should always be 6 spaces, no matter if you're going horizontally or vertically. The one thing is you can never put stations on diagonals. It has to either be vertical or horizontal. But yeah, they'll have 6 positions. So I'm just going to put like right here in the middle. This is theoretically coming from some miners. I'm going to need some power, but we'll just do pretend power. Great. And let's say we got, you know, some coal coming in from our miners. Here comes the coal. There it goes. You can see it's not really pulling off as fast as we're providing the coal, but that's fine. This is going to load up the cargo wagon. A cargo wagon is slightly smaller than a steel chest. A steel chest would have 48 slots, which would be 4 rows, and then 8 down here. This only has 40 slots. And that's it. Basically, we can now manually drive our train over. As soon as this train starts moving, these inserters stop. We get over here. This time I did hit the end, actually kind of went a little past. If you see now, we're still misaligned, but we can... The misalignment doesn't really matter for the inserters as long as they're able to pull material out, and we can put like another belt here, and that can go off into our factory. Let me stick this here to not overlap so you can really see, and I'm just going to run this down because we have power over here. Probably should have put power over there because having it in what should be our factory makes more sense. Now here we are unloading, and that works. Now we're not really unloading fast, just like we weren't loading fast, but this will get you materials. A train for ore generally holds 2.4 thousand ore. For plates, it would be double that, so it's 4.8 thousand, and that's just because ore stacks in 50s and plates stack in 100s. Certain things like circuits stack in 200, so you get even more. Let's say it's, I believe, 9.6 thousand. Now that we have 2 stops, and let's say we have researched automation, you know, we don't want to drive the train ourselves all the time. We can click on the train. Clicking on the train gets you this UI window. You got a little map here which you can flip to a direct view of the train. When clicking on color, it actually does that automatically. You can set the color of your train. So if you know this is for coal, you want it like black because it's the color of coal. You can do that if you want. This shows you fuel. We currently have 49 coal in it as fuel, and you can set a schedule. So we want to set a schedule so we don't have to automatically drive the train. So I had called that get ore is where we want to go to, and we want it to stay there. You know, this is the wait condition. How long do you want to stay there? We want to stay there until our inventory is full, and then we want hitting plus again. With this, hitting plus will add a station after the highlighted station, and basically this is a list of do this, then do this, then do this, then do this. It's a list. You can, I'll show you, drag to reorder. If you want to remove one, you can click to remove one. If you want the train to go to a particular station right now, you can click that station to highlight it, and then you click the go to station button. So we want to now add the, I believe I just called it drop off, and we want to wait until our inventory is empty. And so we'll go get ore, wait until the cargo is full, then go to drop off, wait until cargo is empty, and then it repeats. We could have more stations in there. We could have more conditions, so you can say, hey, wait until the cargo is empty, or you've waited for 30 seconds, or, a minute, 60 seconds, because you may have multiple trains, but that's kind of getting ahead of stuff. But you can add more than one condition, and this will be or, which means either. If either is true, it will leave, or you can say and, so you have to wait until you're empty and it's been at least 60 seconds if you want that. And again, you can add additional conditions with the plus. You can remove conditions using the trash can. You can get, I don't think I actually mentioned this, pressing enter will enter the train. You can have someone in each section, so you can have one player, if you're playing multiplayer, in the locomotive, another player in the cargo wagon, even if it's full, and another player in the back locomotive. I believe you can drive the train from whichever, as long as you're the only one on the train. I believe if there's multiple people, you have to be in a locomotive to control it. I'm not actually sure on that, though. So let's just get in the train so you can see. I will now set the train to automatic. It will go to get ore. And it will stop right exactly at the right position. We will load ore, and this will take some time. And then we'll go back. So let's, how do you want these loading things to work? Well, if you got stack inserters, you definitely want to use stack inserters. They'll go faster. They move, up to 12 items at a time instead of, well, these are just 4, I believe, fully upgraded with research. You really don't want your stations, because there's 6 spots, you kind of want to use all 6 if possible. Let's put, there is a space between each car, so you have space for a power pole between each car. And, you want to use all 6 if possible, so it's best to use both sides of the belt. And if you put a splitter here, you can basically now, we're filling a whole blue belt, which will be 40 items a second. Now, really, you don't even want this. There's better. What you really should do is have some chests. That way, inserters pull out of chests. Ooh, we're on our way. We're 2,000. Why did I think it was 2.4? So, you can see, we came back, and we have a full 2,000 of ore that we're unloading. But the same thing with the unloaders. This is going to take a while. Let me show you the simple yeah, let's do this on the other side. If you're not aware, inserters take things out of chests a lot quicker than they take them off belts. Basically because the items are moving on the belts, it takes them longer to grab. So if you have the technology and the resources, you want something like this. And even if you don't have the technology, you want fast inserters. But this way, while the train's not even here, we're putting items in this chests so that when the train does come, we can take them out of the chest really quick, and we don't have to wait for them to come down the belt. And using something like this on one side of a wagon will fill the wagon relatively quickly. If you want to fill the wagon even faster so the train doesn't have to wait even that long, you can do this on both sides of the belt, and the train will get here, get loaded even faster so it can move. And you always want the train moving. A train that's not moving, is wasting time. You want the loading and unloading to be as short as possible, so that it's moving items, because that's what you're trying to do. You're trying to move items. So if the train's not moving, you're not moving items. Let's see how we're doing here. Okay, that is almost done. Just a few thousand more to go. A few hundred. Down to 500. So just like you have this for loading, you can do this exact same thing for unloading. Just turn all these arms around, turn the belt around, turn the splitter around, and that's a decent way for unloading as well. You put it right into a chest, which is faster than putting items onto a belt, because you don't have to wait for the items to move out of the way to put down the next one. And then you can take out of there, so once the train leaves, you're still taking out of the chest and putting onto the belt. I'll set that up as soon as we show this. Here we come back. So here you can see we're going quite fast. Almost 100 a second. And, there we go. Because the chests were full, we were able to fill this really fast. So you can, as I was saying, do the same thing for unloading. Leave a gap, put 6 chests. And then a splitter to merge them all together. I'll put the power poles like that, and this will unload very fast, because even though you can see these are waiting to unload, we're still able to unload into the chests. And when the train is all empty, the chest will still have a few hundred that we can continue unloading onto the belt. And there are better station designs. I'll show you a few. Well, one that I seem to like a little bit later. You need to handle fluids differently, though. See how fast that train comes back. Same basic setup. Oh, and generally, you're going to want, at your stations, a way to refuel the train. It doesn't, like, at the station in your base. Not that. We want one of these. And it doesn't need to be fast, because even on just coal, the train doesn't take that long. It doesn't use up that much coal. So you can see here, we're now automatically filling the train with coal. So on the lower right there, you can see the 101, 104, 107. That's how much fuel it has. It will hold up to 150 coal. The lower number was this cargo, which in this case also happens to be coal. So fluid wagons are basically the same thing, except the station is just slightly different. Again, you want the station on the right-hand side. We'll put down a locomotive. Definitely build the trains in order. I could theoretically put this down, but if I'm slightly off, it won't snap here. If I'm slightly off putting down the wagon in the middle, it isn't going to correct it. It's much better to put the wagons down in order. You can see the green connection. That's going to say they're linked. You actually can, if you're in a train, let's give this train some fuel so I can kind of demonstrate here. I believe it's a V to disconnect, and then I can back into it and press G to connect. As long as you're not, too far off, it will connect. Those are the default keys. you may have changed them. But just putting them down like this, you can see the green connection icon or symbol, so you know if it's connected or not. We'll give you fuel as well. For loading and unloading liquids, you need to use pumps. And when you bring a pump close to a rail, you can see where it will connect. Now, it looks like you can put multiple, but the pumps connect to these little nozzles on the top of the tanks, and you can really only have 3 connected at once. So if I will call you L1 for liquid 1, and I'm just going to say go to L1 until we'll make this the filling station. Inventory full, and I say automatic. Alright, let's put you back to manual, and I'll drive you back a little. So you can see only 3 of these pumps connected. The others aren't being used, and that also includes, like, if I had them on the other side, only 3 from one side. It doesn't matter if it's here or here. It's just, out of the 4 positions that can access this, because there's 4 here, 1, 2, 3, 4 here, 1, 2, 3, 4 here. Only one of those, each of those 4 will connect. If you want to unload, you can just put it so the arrow faces away. It still connects, but we're going to make this the loading station. Really, you don't need that many pumps. I'm going to remove the pump for now. I'm going to set up this for your void. We're going to make this crude oil, and you can see it's able to fill this tank real fast. One of these cars has the same amount of storage as 1 tank. So I remove that, so nothing else is going to go in this tank. We're going to put down 1 pump. It's going to connect, and you can see it can fill the train car really quickly, and it completely empties this tank. And it holds exactly the same amount, but that's only true if you're pumping directly from a tank. If I put this tank here and fill it with crude, alright, and I'll put the pump here, and we'll connect it with some pipes. It takes a lot longer. Like, it would have been done already. And so as much as possible, you want to have tanks right along and being pumped directly into your train. See, we're still not even done, and it gets worse as this gets lower and lower. It slows up more and more. And yeah, we're not even done yet. Still a little bit to go. And it's going really slowly. Yeah. 6, 5, 4, 3, 2, 1. We can get it all just about there. And we're basically done, but there's some trace amount. That's why the icon is still showing where we were able to completely clear the tank before. If you plan things out correctly, you can get, of course, when I say plan things out correctly, those will connect to 2 different. So we can now pump out of these 2 tanks into here, and that would load really quickly. You can only get 2 like this per train, because if try to go like this, like, hey, we're on the next train car, there's no way to get a pump directly out of this tank into this car. But this is going to fill basically twice as fast as my first example. So for unloading, we'll come over here, and we'll do the same thing. We'll stick down a station on the right-hand side as viewed from the train. We'll have tanks coming out, or pumps coming out. We'll pump directly into tanks. Same reason, if you have a long pipe, it's just going to take longer. You pump directly into tanks, it'll go real quick. On this side, I'll put a fluid void, and this will just suck up the fluid, but pretend it's going into our refinery. And the only thing we need now is power, and that will be good. We'll make you L2. So I'm just going to get in here, and we're going to say now go to L2 and inventory empty. Inventory full and inventory empty is what you can use 90% of the time until things get complicated. So here you can see, yeah, that's basically instantaneous. It took like a second and a half. Now what I can do over here, I'm going to just remove that. I'm just going to put 1. But even that, some is going to flow into here and then get pumped up, and you can see that's pretty quick. Now, you're never going to have your pump jacks filling it that quick. But if it's a long way away, you have the tanks there for storage to hold, for the same reason we have the chests. If you were pumping directly out of your pump jacks, nothing would move until your train got there, and then it would only go at the, 10 per second that your pump jacks were actually outputting. That's definitely why you want the tanks. Now, you can see these tanks are actually full. Do I have these the wrong way around? Or yeah, I had them the wrong way around. So now these will drain, and we can pump out of the tank. Basically, for any of these, if you're not using the items and they get, the items or the liquids, the train will just wait until it is empty, because hey, that's what we told it to do. Now these are relatively simple. You start from one point, go to another, but that's all you really need at the beginning. So this is a slightly better version. We'll say it's copper, because now we have 4. We have 2 cars. The train is going to be able to carry that much, and now we're filling from both sides. So this is going to fill a lot faster. We're going from source A to desk B, and because we're filling from both sides, we're filling at twice the rate. So if you need more ore, you want to add more cars. Now eventually, as you add more cars, your train gets heavier and doesn't accelerate as fast. And now that may not be too much of an issue, but once you get to a ratio of 4 or 5 wagons, and to be clear, a locomotive is the same weight as 2 cargo wagons. So this is the same as if I had 1 engine pulling 4 cargo wagons. But once you get above that, a lot of players think everything is too slow, so you can actually double the locomotives. A lot of people run 2 locomotives, 8 cargo wagons, and then another 2 locomotives. And that works. That gets the speed up. You can also use better fuel. Coal is basically the default. If you then use solid fuel, that will give you like a 20% extra acceleration. You can also use rocket fuel, which gives you 80% extra acceleration, and then finally nuclear fuel, which 250% acceleration. The problem is, well, not really a problem. Nuclear fuel lasts a long time. It's got 1.21 gigawatts, but they don't stack, so the train can only hold 3 of these. Now, I've never had a problem. You can go a really long way on just one of these, so having 3 will let you go pretty far. So you can see here, now that the stations have, some in their chests, this loads really quickly and unloads really quickly, but it's still not the best. We'll get off here, but this is basically doing 2 blue belts per train wagon, but it is possible to do 3 blue belts. Let's do iron ore here, and then I'll just copy and paste this. And what are you called? Oh, you're A and B, so we'll set you up to source A. Let's check the map. Source A and dest A. Makes sense. Add, go from source A. It would scroll with the scroll wheel. It just doesn't. Full, and then we will go to dest A and inventory empty. Now you could, if you really want to, do mixed trains, so it goes to one stop, picks up some iron, and then goes to another stop and picks up some copper, and then goes back. And for that, you can say, oh, I want, go to the first one and say, we want to pick up iron, and when it is greater than or equal to 2,000, and then go to copper, and then wait for that, copper to greater than or equal to 2,000, and then you can go back to, your factory and then say, when empty. But, like I said, that's a little on the complicated side for starting off. Alright, so we're just going to set this to, and you can see, we're taking a blue belt, splitting it, going underground, but also pulling off to put into this chest. What doesn't get pulled off comes over here and gets put in this chest. And so we're basically having 4 inserters pulling off of 1 blue belt using a splitter and 2 undergrounds. And using that, we can get 3 blue belts per cargo wagon. There are better ways, but usually they're more complex and not that much better. For unloading, it's basically the same, except I have this little curved belt here to merge it in, because basically they both unload on the same side. But with that merge, it works well. I'm going to go back there just so you can get a little closer view of the unloading. So again, we unload into chests, then onto an underground belt. This one also unloads onto underground belt. We have this just a balance and a curved little piece, so we fill up the belt here. Doesn't matter what the orientation is, these will happen to always put on the right side of the belt. And so while the train is here, we get a pretty good stream. We get almost 3 full blue belts. They're not quite fully compressed, but they're really close. And then it will just last a little bit longer after the train leaves. So you got just enough time for another train to pull in if you're doing that before it runs out of ore here. Yeah, there's starting to run out. And yeah, one side, the far side, happens to unload a little bit faster because the items here prevent these inserters from unloading. Alright, this is all well and good when you just need to go straight and you don't need to cross tracks. Once you do have to cross tracks, though, you're going to run into some problems. Something like this. Let's say we have our bases over here in this case. We got our iron unloader happens to be here, but the iron mine is up further on this side and the opposite for the copper. So eventually, you're going to run into some issue where... Alright, well, we made it that time, but, you know, now they're going to unload. And, let's just tell you to go. I wasn't quite quick enough on the draw there. Let's... go now. And... oh no. Yeah. You're gonna get the trains crashing. Manual, have to get in this one, and... let's put you on manual as well. Can we... oh, now we can back him up. And, you know, then we get out our repair, and... it's a big mess. Let's just have you guys go back, and then I'm gonna stop. Stop. So how do we deal with this? This is where signals come in. There are two types of signals, but the basic one is the rail signal. It's basically a stop-and-go light for the train. So, in the case you have your rail system set up like this, with double-headed trains on a single track, again, just like the stops, the train is only going to pass the signal if it's on its right side, like this. So this train will come and be able to pass the signal. If you put just a signal on the left side, well, the train here sees red and is going to consider that red and not be able to pass that signal. To show, I will, say, hey, go there, and it's going to say, hey, there's no path because I can't go through this signal. This signal only allows travel towards this stop. So the way to deal with that is you put a signal on both sides. Now this train will see, there's a signal here, but I can go past it because it's on my right side. The thing is, this signal right now is red. So if I say this train to go, it will come up and stop the signal. Well, why is this signal red? Well, let's discuss. While holding a signal, you'll see there shows up these lines on your tracks. And signals break up the tracks into blocks. Now, these signals are based on real-life train signals, going back to the 1800s. And they didn't have, lots of fancy electronics then. They just had some simple... most of it actually was mechanical-based. But what they had back then sort of operated on these same principles. If the signals break the tracks up into blocks, if a train is anywhere in a block, like in this case, the blocks are colored. We got a red block here, and the whole rest of this is a yellow block, even though these two tracks don't actually... you can't get a train from one track to the other. They're considered the same block just because the tracks overlap. So if you have a train in one block, no other trains are allowed to enter that block to stop them from colliding. So because we have a train in this yellow block, this signal is red, disallowing this train from entering the yellow block. Well, how do we get this train across this track? Well, we have to get... if we put this intersection in its own block, then no trains would be in it at the moment, and this train can cross it. So if we just put... as soon as we did that, see, this train is now no longer in that block. However, now this train has the same problem. There's a train in the red block, so it can't cross. Well, what do? Let's put signals here, here, and here. So now we have one red block and 4 yellow blocks. Now, even though these are all yellow, they're not connected. They're different blocks. It just happens to be using the same color. It could be the view, like here, will also use white and cyan and blue if needed, but generally that's only used if you have a lot more trains crossing. So let's start this train up. Oh no, they're going to hit. Oh wait, this train stopped because its signal was red. Now once this train left the block down here, the signal turned green and it could enter the red block. You'll see, alright, this train is in the red block. These signals turned red. Oh, he left. The signal turned green. So this train can now enter the block. This will work. It's not the most efficient. Really, you want these signals as close as possible so that the red block is occupied for as little time as possible, so you're stopping the other trains as little as possible. In fact, we can move these closer. Yeah, there was cyan. This is pretty good. Like, if I had made this straighter here, I theoretically could put the signals, like... you can see, like, these signals are flat against this track, so they're for this track. Certain places, like here, well, when you place a signal, it will highlight, like, this has now made this a one-way track. He should be saying no path, but it highlights the white is where you need to put one if you want it to be two-way. But generally, there's no such thing as too many signals, but, like, this is overkill. There's never going to be a reason to have a, small blocks like this. So, in fact, I'm just going to remove this all so it's down to just the important ones here, which includes this one, so the train can go. But this will now prevent these two trains from colliding. Now, this is probably a little too minimal. You may want to spread them out a little, but you can see we have a red block here and then other blocks. And if there's a train in the red block, the signals turn red for the other train, stopping that train so they'll never collide now. And this, for a good portion of what you're doing, if you just have a train, double-header trains, each on their own lane, this will suffice for your factory. Well, what if you're not using double-headed trains? What if you're using single-headed trains? Well, single-headed trains, you generally need a loop. And this is kind of exaggerated, but, this is a loop. Let's get you loading coal. And, oh, yeah, you're on manual, automatic. So as soon as he's full, he'll take off. He'll go slightly faster because he's not pulling another locomotive backwards. The backwards locomotives don't help at all in automatic mode. They're dead weight until they're pulling in their own direction. So this train will accelerate slightly faster. Almost there. 4,000. Here we go. It's not that noticeable, but, it's there. So now he's unloading, and he'll go back. That's great, but what if we, need more coal, and we can supply more coal from, this mine? Let's say we got a giant mine here, and, it basically fills up these chests before the train can get back. Well, what do? Well, we can put... I'm going to wait till the train comes back over here. Yeah. It's wrong. I'm going to put you on manual just for a moment. So I'm going to put the locomotive down, give him 2 cars, and I'm going to shift and right-click, and then shift and left-click, and that pastes basically the schedule. It'll also paste the color if I've customized the color. So I basically copied the instructions that this train had. So now I have 2 trains, so I can send this one to go, and then I can send this one to go. And they're okay for the most part. See, he leaves, and now he leaves. And this looks okay. The problem is, well, what if this mine starts slowing down, and so it takes longer to load, or we do have a crossing here with signals, and the one train has to stop, and eventually the other train catches up to it. Eventually these trains are going to crash and collide. But we can stop that with signals. So basically what you want to do, again, the signals go on the right-hand side as viewed by the trains. So you want to put a signal behind. Oh, there was a collision. That's not what I wanted to do. Oh, yeah, the trains happen to remember, so I didn't actually have to paste that back. So you want to put a signal before and after each station. I didn't quite get it down in time, but that will be read and prevent this train from hitting. The problem is, this train isn't going to leave, or, well, he'll leave, but then he'll stop here, because the whole rest of this loop is one block, and he can't enter it because there's another train on the block. You need to put a signal down before and after each station. So I'm going to put it there, and now he can leave because, hey, it's a different block. Now this will work, but it's not as efficient as it could be. If this train finishes up first, it's going to have to wait. So basically, you'll want to put down additional signals every so often, generally longer than the train, but not too much longer. That way, you can have the trains following closer. Basically, I'm gonna have this one not wait. Let me remove these signals here. And if I said for this train, go drop off now, well, if you had more trains on the loop, if I had 3 trains and I had a train waiting here, let's do that, because that will make the demonstration a little clearer. We're gonna copy, paste, and then give you some fuel. And so yeah, let's say we need even more, or now we have 3 trains. We have this train waiting here, this one's filling up, this one's dropping off, but when this one goes to go... Oh. Yeah. I screwed that up by having the extra signals already. Again, I didn't mean to do that. There we go. Go. So, this train now can't leave this station because this one's already waiting on the track. We're waiting for this one to load up. So the idea is, if you put down periodic signals, he can leave and he can wait here until the way is clear. And we do the same thing here. This just allows the trains to follow, okay, he's leaving, and he can get pretty close to the station now before he has to stop. So by having periodic signals, you can have the trains following closer. Now, if you build out a big network, this helps a lot more than it seems here, because right now they're all going to the same station. But what if this was your base and you had track going out and then splitting off to a few different mines. Well, if you didn't have these signals, only one train could be heading out to the mine at the time, and only one train could be coming back at a time. But by having these signals, this allows multiple trains to go out or come back as long as they're separated by at least one block. So I can, like, hit go here, and, you know, if this train was still at this corner but now just pulled in, he wouldn't have had to stop at all. So generally you don't see a loop like this, but we'll get to exactly what you'll see later. Now, you really don't want to be doing what I'll be showing here, but occasionally you'll have some tracks like this. It's a single track, but you want to use it in both directions by multiple trains at once. Again, let's say this is your base, and your mines are out here, and you have a large section of track that is shared. And let's say this is your iron drop-off, and this is your copper drop-off. So they do have to cross, and this is a lot longer than it looks here because you went, 1,000 blocks sharing sharing the direction, or sharing the track that you need to use in both directions. Now, if I put these trains here like this, and okay, we'll call you 1, 2. I don't have a 1 and 2. Great. We'll call you 3 and 4. So 1 goes to 2, 3 goes to 4. Now, it should be obvious right away that if I start these trains, they're going to crash. I don't have any signals here at all. And then you may think, okay, well, let's do what we did before, up here with this crossing. Really should have put down some radars. Well, this looks good, but this doesn't work either. We'll say go to 1, fill, and then go to 2, empty. We'll leave that for the moment. Go to 3, full, go to 4 until you're empty. So I can start one of these trains. And he works fine. I can start this train, and he apparently works fine. Great. Look at that. But actually all is not right here. So if I have this guy go, well, that was going to make it. Let's have this guy go now, and this actually may be okay. The problem would come in if you have more than 2 trains. So if we had this connected up, so this copper, let's say our copper drop-off station, let's do it the correct way, had another line going off, so that another train could come in here to drop off copper, and I'll wait for this guy to leave. It should only take a second or two. So if another train now pulled in here and stopped, now we have a problem. Because this train is going to come here and then see a red light and stop. But he's blocking this train. And yeah, maybe it will fix when this train leaves. But if this train also came in off of, like, this branch, yeah, you know, if this wasn't here, really the, oh, like, that train came off of this way, you've now got a problem. So I'm going to remove this train, and we're going to stop everybody. This is where you need the other type of signal, the rail chain signal. So where normal signals just say, hey, this block is occupied, I'm not going to let you enter it. Chain signals go one step further. Did not mean to do that. So chain signals still look ahead to see if the block is occupied. And the way I have this right now, it is. I'll put it like this. Now it isn't. You can see coming this way on the right, hey, we're green. But if we come this way on the right, hey, we're red. Chain signals additionally not only check to see that the block ahead of them is clear, but that the exit of that block is green. That means they check that not only is it safe to go through the block, but that the train going through the block will also be able to leave it. That way, if it's green, it means you can not only get into this block, but you can leave it without blocking other trains. So if I just have this train come over here, and we'll set up the same thing. We'll leave this train stopped here. He'll get filled, but I will put, hey, the other train pulled in here. You can see at this point, this turned blue, which means, hey, if it's not red or green. If it was red, that means you can't enter it. If it was green, it means if you can enter it, you can leave. Blue means, hey, you can maybe able to leave or not. You have to check your exact path. So if this train was to leave, it may or may not stop here. If this train was going over here, it would say, oh, yeah, your way is clear. You got a green exit. You can go. But if this train was trying to go here, this signal would turn red as the train approached it. Basically, the blue means it depends on where you're going. As you can see here, though, this train wants to get over here, and his signal is... This block is clear, but the exit signal is red, which makes this signal turn red. It says, hey, you can't go because your way is blocked. So if we now turn on this train, he can still go because this train did not try to go and finally get stopped here, blocking the whole track. Now, really, if you had this situation, you would not want those signals there. Let's tell him to go back. You would want these signals here. And then here, you can see this is a green, so this train would be able to drive along this path, assuming this guy wasn't, in the way. This train would be able to drive. Oh, look, we're okay. We're okay. Green, we can leave. So let's do that. He's left, pretend down this way. Hey, now this train can go. He can get here, and then as soon as this train is out of the way, this train can go this way. You want to use chain signals in a situation like this where you have a section of track that you never want a train to stop on. I want it properly signaled so trains don't crash, but I never want this to stop, a train to stop along here. Now, generally, this is more complicated than you want, but generally along a section of track, you know, we'll have some track here. We'll have, you know, he comes in here and then goes off this way. If you never want a train to stop here, you want normal signals. And let's say this was coming south, and this was coming, you know, we're going to the right / south on all of these lanes here. You want a normal signal at the exit points, and you want the chain signals at the entrance points, and possibly in the middle if that helps break up into blocks. In this case, it doesn't really make a difference, but there are cases where it will, which I'll be showing you next. So yeah, here's a kind of more extreme example. This is our factory. We would want a, you know, this is not signaled right at the moment. We would want a normal signal here and here, because that's the exits of this long block. Here's the entrances, you know, going the other way, so we'd want chain signals. And again, you can see the white, we need a signal, but it does not necessarily need to be the same type. As long as any type of signal is here, this allows two-way traffic. So for the entrances, we use the chain signals. At the exits, we want a normal signal. We'll make this one a chain over here. And kind of the same thing over here. Well, this doesn't have any signals, so we'll put a chain signal there and a normal signal here. Now, this will work. What are those? Iron load and unload. Alright. This will work, but it can be improved, and I'll show you that in just one moment. Let's get these down. And, you know what, we'll give you some solid fuel. So your coal unload. Coal unload, empty. Coal load, full. Iron unload, empty. Iron load, full. So we're gonna have these guys go, and you'll see he's using the track. He'll wait, but he's got to go a far. You can see on the mini-map, he has to go a long way until this guy can finally go. And now this guy wants to come back, but he has to wait for this guy to get into his station. You know, before the, you know, because basically this whole big Y is one giant block. Well, what can we do about that? Well, we can't do too much about this section, but what we can do is something like this. And in fact, I can put like that. So now, as soon as he passes here, he wants to go down this branch. So as long as the other train is on this branch, he can go. So this is helping. You know, now that he's there, this train can use this. But he, you know, there's still the shared part, they can only use one at a time. But once they don't want to use the shared part, they can use the individual parts at the same time, just not both heading towards the shared part. As long as like he's going here, he can now go right away because the path that he wants to use doesn't have any trains on it. But again, you generally don't want to use this because you can see only one train can use this track at a time, and you're going to basically slow the train. Like, hey, this train has to move, wants to move, but he can't move, or else he risks hitting the other train. And trains that aren't moving aren't being useful. They're not moving your items, and that's their whole purpose, is to move your items. So you generally don't want to do this. You know, maybe if you're really low on steel, this is something you want to set up, but not for the long term. So how do you want to set up your trains? There's a few ways to do it. You can do it like I've been showing, mostly double-headed. Personally, I like single-headed trains, but more people use double-headed trains, so that's what I'm showing. You want to use one rail in each direction, and something like this, and you're going to wind up with intersections. I don't have any trains here, but so I generally use right-hand drive, which means the trains drive on the right-hand rail, and your signals go on the outside. That's because I'm in America, and that's how we drive on the roads. Other people use left-hand drive, where this would be the down direction, and your signals go on the inside. Some people like that because that's the way the car driving in their country goes. A lot of European countries use that. Other people like it because it keeps the signals on the inside. And, you know, so it's slightly narrower. But it's mostly up to preference. You can build systems either way. You generally should stick to one. It is possible to mix, but generally where it mixes, you have to have crossings, and that's just more complicated. So we're going to do this right-hand drive. So, like I said, you want normal signals at the exits. This is an exit. This is an exit. This is an exit. This is an exit. Now, you see all these things blinking. Why are they blinking? Well, they're saying, hey, you have me down, but both sides of this track is the same block because, hey, look, if you follow this all the way out on the map, they merge, so it's the same block on this side, and you can come around, and then we're all one block. Well, when I put down other signals, we'll fix it. So I said you want chain signals on the entrance. So this is an entrance, and look, hey, we fixed this. It's now no longer the same block on each side. This is an entrance, this is an entrance, and this is an entrance. And this will work, just not efficiently. So let's say we have a train heading this way and a train heading this way. Well, this whole central section is one block. So only one train can be on any of these blue tracks at a time, because when one train is, all the signals, at least the entrance signals, will turn red and not let another train enter it. But that's not efficient. We want a train to be able to pass in, you know, going north and south at the same time. So how do we fix this? You know, or going east and west at the same time? Well, we put a signal, a chain signal. You know, we don't want a train to stop here, so we only want, you know, we only want a train to be enter here if they can exit. And so we want to change signals, you know. So if this turns red, that means this will turn red, which means this will turn red. That's why they're called chain signals. They only ever look ahead one, but if the next one is also a chain signal, well, that one looks ahead one, so it's basically like this one gets 2 look-aheads for free, or 3 look-aheads, or however many chain signals there are in a row. Why is this blinking? Well, again, like, hey, this side is a block, but it's the same block on the other side. We need to do that. Hey, now the northbound and the southbound rails are different colors. That means a train could go northbound while at the same time a train is going southbound and not cause an issue. East and west, though, still use both colors, so that would cause a problem. But hey, we just split these up, and now every direction is, separate from the blocks in the other direction, and that way a train can pass east and west at the same time. But if that occurs, the trains going north and south will be stopped until those east and west trains are out of the way. Similarly, a north and southbound train can both pass at the same time, but that would cause the east and west to stop. But hey, that's as efficient as you can get. The thing is, this is just a simple intersection where you can't actually go from north-south to east-west. How would you set that up? Because in a big complex network, you kind of want a train to be able to get wherever it wants in your system. So let's say, this is iron and this is coal, and we have a patch of iron out here, and we have a patch of coal here, but then we find another patch of iron down here, and we need this iron train to be able to get there. Well, in that case, I'm going to remove all these outer ones. Now, everybody's blinking, but we'll fix that in a moment. In that case, hey, you put... Let's do this. Down. And rotate. And I didn't start you high enough. There we go. You put in some curves like this, and again, this for me is north going up, so we put, it's the exit, so we put the normal signal at the exits, and we put the chain signals at the entrances. And this would work. If we're going north and south at the same time, we can do that. If we're going east and west at the same time, we can do that. Some people will put signals there and then here as well. It's not really necessary. Let's hold one so you can see. I say it's not really necessary because while it does further break this up, you're not going to get a train turning here, which would, having this as a separate block, be helpful. Unless, for some reason, the train stopped and was partially in this block, this blue one, but it stopped before being here, so then you could have a train go straight. But generally, when you have a normal signal, you want to have enough track so a full train can stop after it. That way, you know that, hey, if this is green, you can... if you had another chain signal here, well, a train could stop right here. Let's pretend that's the back of a train. So that your next train would come, and while it sees this as green, and hey, green, oh, we need to stop this red one, and the back of it is still hanging here, which is what you don't want. So you wouldn't want a signal right here causing this train to stop without enough room for all of it to be out of the intersection. So now you come down here, and you make a T intersection. A T intersection, like, this is a cross intersection. Well, a T intersection is, hey, you just cut this off, and, this isn't entirely correct. Like, if I'm coming this way, I can't turn here. So you also need a turn like this, and if you're coming south here, you basically need all the left-hand turns, and I left them out. If we're coming this way, and then you're missing your left-hand turn this way, and hey, wait. Now we're all the same block again, because things get complicated. There are ways of doing this right. You kind of need to space the tracks a bit further. It's probably better just to use an existing blueprint. Look at Factorio prints. This should be fixed. I got some spare track in there, which I did remove, but I also removed the existing part. That should be fixed again. Generally, it's easier to make something like this, a roundabout, but roundabouts can cause their own problems, and again, signals properly. I'm again using right-hand drive. You want a regular signal on the exits, a chain signal on the entrances, but you want to split the roundabout up as well. Like, well, maybe not like that. Probably more like this. So now you can go north and south at the same time without blocking each other, and make your rights. And rights block very little. You can make 4 rights at the same time, but lefts block a lot. Basically, left will block most of the roundabout. This guy could make a right while another train was making a left, but only in that case. A left is going to block direct through traffic. But it's only, it should only be blocked a short time, just enough time for the train to get through. This is much easier to make than, trying to do a full correct intersection by yourself. In either case, this can be turned into a T-junction relatively easy, just leaving off one branch. Normally, a T-junction would have to be... ooh, sorry, that was loud. I'll stand away. We'll have this coming south and going this way. We have a track coming this way and then heading south. And then for north, you kind of hit T accidentally instead of R for rotate. Something like that. I mean, that's not too even, but again, we got the normal signals on the 3 exits, chain signals at the entrances, and now we want to break this up into blocks. So we definitely want let's move that a bit. We're gonna really, we'd want this normal signal back here, but at least now, yeah. now we could go north and south without blocking each other because we've separated these. And we could turn south here while turning west here, or west this way. And, or vice versa. We could turn west here while turning north here, also without blocking each other. But a turn with a north or south straight, one of the trains is going to have to stop. That's about all I have, except I will throw in my quick warning. Oh. Before the quick warning, if you want single-headed trains, because they are slightly faster, you need to have a loop at each of your stations. In this case, you'd only have one signal here. You wouldn't have this, and you'd have a signal here leaving, and maybe here. So your train, instead of turning, instead of pulling in and then going out, you just pull in and then pull out and circle around to the return track. That's generally how I do things. It's slightly more realistic in that while there are trains that do have locomotives on both ends, it's generally much more common, especially for big cargo trains, just to have a bunch of engines at the front pulling in that one direction, rather than just pulling a cargo engine backwards for your long trip. But in the game, it doesn't really matter. I just kind of like this. Mostly because, again, slightly because it's more realistic, but also partially because you're not pulling some dead weight around, and you get slightly better acceleration without needing additional locomotives. The one thing to watch out for with single-headed trains, pretend this was a roundabout. Actually, I can make it a roundabout, sort of. Alright, that's just one extra straight that got put in there, but pretend it had other exits. We're going to put some... Now, this happens to be left-hand drive. Now, this is what you would call properly signaled. We got, chain signals going in and in the middle of intersections, basically, and only normal signals on the exit. And, pretend there are other exits, but if you're not aware, you can hook stations up to the circuit network to turn them on or off, and if a train is heading towards a station that does get turned off, it will immediately repath to another station. So, in certain cases, we want to go to this station. I'll call it issue. And we're going to come from a station over here and pretend that there was another station we were trying to get to, but it was turned off, and so we say, okay, let's go to our next destination, and that happens to be this one. While we're going around the roundabout, so we were going to, let's say, leave the roundabout going this way, but as we enter it, something happens that just makes us decide, oh, we need to go to this station now. I'm going to put a single locomotive. I'm going to put a bunch of wagons, because This is really only an issue on longer trains. Um, but, I mean, it could happen in any train, and we're going to take... I believe these can be used for fuel, because we want that train to go slow. So we're going to tell it to go to issue. It doesn't matter. And it's going to go. Now, pretend, like I said, it was going to go somewhere out, but once it got into this roundabout, it figures out it needs to go over here. Hey, wait, the signals are red. For some reason, a train won't stop for itself. Even though the signals were red, the train's like, oh wait, that's just me. That's not another train. I won't stop. But it causes a problem. Now, I've never, as far as I know, have seen this in an actual game without purposely setting it up like this, but it is a possibility if you use roundabouts and longer trains that the train can wind up hitting itself. The solution is make your roundabouts bigger than your biggest train. That's not always possible. Just be careful when you use roundabouts. But otherwise, the rules, that I said, normal signals on exits of intersections, chain signals on entrances and in the middle of intersections, and you're generally good. You won't have any trains colliding, and no train should be held up longer than how long it takes a train to get through the intersection. That's my basic training. Thanks for watching.